Before we begin this journey, take a moment to settle in. If you're watching this to unwind, let your breath slow. If you're here to study, let the vastness of space widen your focus. And if you've ever gazed at the night sky and felt a quiet longing to know more, this narrative is for you. In 2025, space didn't gift us one explosive headline. It didn't thrust a single mission into the global spotlight. Instead, it offered something deeper, a series of discoveries, some subtle, some enigmatic, that together paint a richer picture of the cosmos. Not bold flashes of spectacle, but patient revelations, like dust settling on an ancient tapestry years in the making. If you enjoy calm, slow-paced space stories with meaning, consider subscribing and staying with us through this journey. Now, let's begin. When we look into space, we are looking back in time. Light travels at a fixed speed. The farther we look, the older the light we see. In 2025, astronomers using advanced telescopes continued to push this boundary in ways that weren't sensational, but deeply profound. One of the most important discoveries was a gamma-ray burst detected in March 2025, known as GRB 250314A. This extraordinary event, a massive star collapsing into a supernova, was observed at a redshift of about 7.3, meaning its light has traveled for over 13 billion years to reach us, making it one of the earliest supernova explosions ever seen. This isn't just a fiery explosion at the edge of time. It's a record-breaking beacon illuminating the universe when it was still young, barely a billion years old. With it, scientists are learning how the first stars lived and died, and how they seeded the universe with the elements that eventually built planets and life as we know it. In earlier years, astronomers expected the first galaxies to be clumsy and irregular, like cosmic toddlers. Among the data from the James Webb Space Telescope, JWST, researchers identified strange cosmic objects dubbed platypus galaxies. These faint objects have characteristics unlike typical galaxies. They don't neatly fit our categories for stars or active galactic nuclei. What makes them remarkable is not just their appearance, but what they suggest. Galaxy formation might be more varied and complex than our theories had assumed. And then, in later 2025, astronomers announced something even more striking. The discovery of the Ulkananda galaxy, a massive spiral galaxy that existed when the universe was only about 1.5 billion years old. This galaxy looks surprisingly like our own Milky Way, with sweeping spiral arms and billions of stars. Yet it existed when the cosmos was still comparatively young. Such a structure shouldn't logically be there so soon, according to older models. But the universe, as it often does, finds ways to surprise. These discoveries deepen a question at the heart of astronomy. How did complexity arise so early? Another quiet revelation from 2025 came not from cosmic giants, but from delicate chemistry. Astronomers using JWST detected complex organic molecules frozen in ices around a young star in a neighboring galaxy. Molecules like ethanol and acetaldehyde that had never before been confirmed in space ice outside the Milky Way. Why is this important? These molecules are considered building blocks of life. They were once thought to form only under very specific, Earth-like conditions. Instead, they are everywhere, even in places unimaginably distant. It suggests that the ingredients of life are not rare, but woven into the fabric of the universe. In 2025, astronomers captured something extraordinary in the vicinity of a distant black hole. They observed spacetime itself twisting and dragging around a spinning black hole, a phenomenon predicted by Einstein's theory of general relativity. This wasn't an explosion or a flash. It was the universe revealing its own architecture. In the invisible dance near a black hole, spacetime doesn't sit still. It moves. It twists. It reminds us that gravity, the force that binds planets, stars, and galaxies, is also a shaper of reality itself. Such observations help physicists test the deepest laws of nature, not in laboratory conditions, but in the wild extremes of the cosmos. Closer to home, the solar system offered its own quiet wonders in 2025. High above our skies, the James Webb Space Telescope revealed a newly discovered moon orbiting Uranus, a tiny natural satellite previously unseen by any spacecraft or telescope. This may seem small, but here's why it matters. Each new moon tells a story of formation, of gravity's subtle work over eons, and helps scientists reconstruct the history of the solar system itself. Meanwhile, ground-based surveys like the Vera-C, Rubin Observatory's legacy survey of space and time, scanned the skies and found thousands of previously unknown asteroids in our solar system, including some that spin unusually fast and others that may one day help us understand planetary formation. And in late 2025, astronomers confirmed something truly extraordinary, that Earth has a temporary second moon, an object caught in orbit that will remain with us for decades. Not a large satellite, but a reminder that Earth's neighborhood is dynamic and filled with surprises. In July 2025, astronomers discovered 3I/Atlas, only the third confirmed interstellar comet ever observed passing through our solar system. Unlike most comets that originate in the distant reaches of our own star system, this one came from another star entirely, a tiny messenger bearing clues about material from other planetary systems. Scientists observed its motion and composition as it journeyed past the sun. And while speculation raced across the internet, careful observation confirmed that it is not an artificial object, but a natural wanderer from interstellar space. These visitors are rare, and each one carries valuable information about environments beyond our own solar system. In a development that feels both humble and monumental, NASA's SphereX mission released its first all-sky map in late 2025. This mission, launched in early 2025, stitched together more than 100 infrared exposures to create a mosaic of stars, galaxies, and cosmic dust across the entire sky. We often think of space as empty, but these maps show it to be rich, structured, and humming with subtle signals. Such maps become tools for generations of astronomers, a cosmic atlas that will be mined for discoveries for years to come. The universe is not static. Stars are born. Stasti. In 2025, telescope networks such as GO2, the Global Rapid Response Optical System, detected thousands of transient events, supernovae, and even the first gravitationally lensed superluminous supernova discovered. These fleeting events offer glimpses into extreme physics, stars exploding at unimaginable energies, or gravity bending light itself. They remind us that the cosmos is alive, changing, and continuously revealing itself. Many of the discoveries we've described, new stars, organic molecules, interstellar comets, may seem small on their own, but taken together, they are systemic shifts. They shape how we measure cosmic distances. They challenge our models of galaxy formation. They expand the known inventory of planetary systems, and they refine how we think about the possibility of life beyond Earth. They reveal that 2025 was not a quiet year. It was a transformative one on the level of recalibration, not explosion. As we close this gentle journey through 2025, remember this. The universe is not a finished story. It is an ongoing narrative, written in light that took billions of years. The universe is not a finished story. It is an ongoing narrative, written in light that took billions of years to reach us, in faint chemical signatures on distant worlds, in tiny moons hugging distant planets, and in the subtle dance of gravity around spacetime itself. If this style of space documentary, slow, calm, informative, and perspective broadened, resonates with you, please like, subscribe, and stay with us for the quiet wonders of the cosmos. Because the universe is not rushing, and neither should we.